A very good day, my dear postgraduate students. The topic staring at us is a SNIP, a short note question, and then a recent advanced topic also, and it is definitely a question for the postgraduates, though it is not our discipline. Let us see what we can unravel in this discussion. And you find that there are many terminologies which we shall be repeatedly using but do not belong to us. And this is the unit of the nanometer. Do not read so much. Look about you and think of what you see there. Richard Feynman, and he is the backbone of today's topic as well as nanotechnology. Now, there is an engineering at the molecular level. Whenever I say that there is an atom, there can be a proton, along with that the neutron, and then there are the electrons in the outer orbits. This is what we know. But then when they do become unpaired, they are extremely powerful, up to having a capacity of creating an atom. There are a range of technologies, and there is a manipulation in nanotechnology. Manipulation by itself is using something or somebody unfairly to your advantage. That is what we daily do. And the applications are in the form of these biochips, microarray, etc., which we shall be seeing. And here again, you find that these atoms join together to form a molecule as such. The Watson and Crick is a classical example of it. There are different types of these nanoparticles, which can be organic or inorganic or carbon-based, and there are multiple other products coming out of it, some of which we shall be touching upon: quantum, nanotubes, fullerenes, etc. And these are the fields. In fact, there is a plethora of fields. Nanotechnology by itself is a separate discipline today. And this is our hero, the Richard Feynman. Drexler is another person who identified the scanning tunneling microscope. In a microscope, you find that you are looking at the eyepieces, and then there will be the objectives, and finally you have got the slide and illumination from below. Whereas in this case, it is the reverse. The slide does be there on the stage, but then the energy is produced by the electrons or the atoms. As a result of which, you find that the picture is being converted into an energy and then fed on to a computer. So this is how it is happening. There is a positioning, and then there is a tube. It goes up, there is an illumination, and finally it is a graphic display. This is what we get in an electron microscope. And that is exactly what Drexler had contributed, and nanotechnology has been there long before it was realized. The origin of nanotechnology. Richard Feynman in his talk. 1959, I like very much. This is a year that is very special and precious to me. And here he is. Drexler had already mentioned the scanning tunneling microscope, atoms, and the other things are there. Fullerenes, for example, was discovered by these people who went on to win the Nobel Prize. You have no responsibility to live up to what other people think you ought to accomplish. Very beautiful saying. And look at the very status of this person. So unassuming. And of course, the brilliance is dazzling behind him. And this is another gentleman, Chintamani Nagesa Ramachandra Rao. And all his accomplishments are there, except that he did not win the Nobel Prize. All other awards he had attained, and a number of publications of books against his name. Most important is that he is an Indian. And there are different approaches to this nanotechnology. This I would like you people to memorize. And this alone is the text of it. There are two major approaches. One is called the top-down, and the other is the bottom-up. So the bottom-up is there are different materials and techniques synthesize their own molecules. Top down is nano objects create from larger entities, and these themselves have got two subheadings or divisions called as NEMS and MEMS. So this is the other one. You find that there is the bulk material, a powdered form, nanomaterial, etc., which are all being derived from the larger particle. Whereas here, it can be the molecules, clusters, or the nanomaterials, and from that you find the physical and the chemical method is being derived. The applications. Applications, look at this one, a field of dentistry. Forget the word dentistry, but see in what all areas it can be utilized. So this you people can make use of. Anesthesia, hypersensitivity, regeneration, as well as encapsulation, endotonic regeneration, etc. NEMS is one. Nano electromechanical system is this. I do not know. Today, the scientists are making devices more functional and smaller while NEMS market is growing. So this is one. Now you find that very small gadgets or chips are running the entire show. And you find that the gadgets themselves are becoming smaller and smaller. But if you do not have one, the entire system can break down. Credit to Shutterstock for this. And the carbon nanotube. So this again is supposed to be one. I'm always reminded of my structure, the amyloid. But here I find there are allotropes of carbon and there is a length to breadth ratio. Lightweight spacecrafts can be there and they can easily penetrate the cell walls. They are used in cancer treatment and mutated regions can be identified in cases of cancer with this. The carbon nanotube. The nano rods, another one. These subheadings I would like you people to kindly note down and mention one or two applications. Again, this is the physics of it, metals and semiconductors, etc. They are ligands and they have got different facets. Again, I am reminded only of the amide. The uses are display technology due to reflectivity in micromechanical systems, cancer therapeutics, and they are having crystals which are stimulated by UV light. This is the group that won the Nobel Prize and again our hero, Richard Feynman. So again, this is one of the book that he has written. There is plenty of room at the bottom. And are we electrons? That's what he said. I suggested to myself that electrons cannot act on themselves. They can only act on other electrons. So also we cannot be acting on ourselves but on others. Noble lecture. And this is the carbon nanomaterial. Look at the different types of these, the carbon black, multi-wall carbon nanotube, graphite, etc. And they are used in a variety of conditions such as the sunscreen, the silver packing, zinc oxide on the sunscreen, garments for warming, and as a fuel catalyst, bandages, etc. So MEMS is another one that we mentioned, microelectrical mechanical systems. So MEMS is one. So there's a other range. Apart from the dental, you find that the spinal disc, joint angle, respiratory pressure, bladder pressure, etc. can be measured. And there's the MEMS over here, a spelling mistake here. Microactuators and microsensors, microstructures, microelectronics. And this is what has been designed by Richard Feynman himself. And which of these is a greater personality? Identify them. Nanomedicine is another one. And in this, it is used for drug delivery, medical imaging, diagnosing and sensing, as well as therapy. These are some of the applications. So a novel vaccine over here. This I would like you people to deliberately follow. You find that these are the dendritic cells and they are present with the nano vaccines. And what happens is these particles are being loaded with it. The activated cells are injected back into the host, as a result of which they can derive anti-tumor response. And the credit goes to this particular reference. And the same thing is being mentioned over here. So it is a cell, the DNA. The DNA itself is very small, within which you have the nano vaccine that is there, and it gets somewhat implemented, just like your viral infection. As a result of which you find it grows, and it can join with other structures such as the antibodies, and then there can be the nano vaccine that is developing against the tumor cells. And also it can be used for targeted therapy. Drug delivery is another system. So these are the nanoparticles. They carry the particles based on the size, shape. Phagosomes are there. So the shapes are here, the liposomes or the phagosomes. These are the surface charges, agglomeration, as well as the size control. Based on these, you find that they are able to deliver the drugs. Again, drug delivery, it's the same thing. You can imagine very well. The RBCs, the WBCs are all there, and these drugs are getting incorporated into the cells, and then they are being carried to their target area. And they can cross the epithelial or the endothelial barriers and used in various combined modalities of treatment. Nanoshell is another one. This is another thing that you people can just go through. And Richard Royer, he is another person who contributed for nanotechnology. There are vaccines also that can be derived from the nanotechnology, nanoparticle vaccines. So the vaccine is over here. Usually you find that they are incorporated, they develop into the B cells as such, and then there are the antibodies which are being produced, and these can get connected with the dendritic cells, and the T cell response is also over there, as a result of which there is a permanent memory and protection against the infecting organisms. Here again, so you find that this is the case of a cancer treatment that is there. So the cancer cells are being attacked by these, and then they are being destroyed. Image credit goes to nanotechnology in cancer treatment. And for those who are not able to follow anything until now, please by heart this. So the applications of nanotechnology in medicine can be a wide variety of things, including the bone, the dental, the nano implants, monitoring, targeted therapy, screening, gene delivery, robotic surgery, and so on. For example, this is one wherein there is a condition of a tumor that has been glioblastoma multiforme that has been diagnosed by this. And again, what are all the various materials that are used for the medical domain? Earlier we were seeing the applications, but now these are the various materials. I've shown you some pictures that can be polymers, metal nanoparticles, carbon particles, nano rods, etc. A few of these names you people can mention. And cancer nanotechnology, it is an interdisciplinary area, merges science, engineering, and medicine. And it provides a tool for fighting cancer. Look at this one. It is a diagrammatic one. Of course, the cancer cell, the spider-like cell is being fought against. So medical oncological applications are there. And nano gold is another one that is used for tumor detection. So it is coated with it, and then the tumor cells can be detected. Sometimes they can be targeted for apoptosis or autophagy. And these are all minuscule beads that are being coated with gold. Tiny transporters is yet another thing. You find that they are being lodged into the cells by which they are being transferred, and they can be used in the treatment of stroke. And when I say transportation, this is what I was meaning. The nanotechnology is not used at the cellular level, but even at the macro gadgets, you find that there are so many sensors in this over here which are being controlled by nanotechnology. And tiny transporters, again, the various surface areas which are being targeted. And there is a nanoshell which is getting incorporated into the macrophage, which itself is activated to attack a tumor cell. Cantilever. What do you mean by the word cantilever? Normally in a building, you find that it stands on pillars, but sometimes you find that there can be a rod of enormous support that can withstand a building of quite a large weight. That is called a cantilever. And why do I use this word in the case of nanotechnology? Here also you find that there is a micro cantilever So these are there, as a result of which probably the surface area or the area of efficacy is being increased, and they are being coated with the antibodies and activated by means of the laser beams. Thanks to this particular reference, these words alone you people should mention. And nanopores. This is a bimolecular lipid layer enclosed between two monomolecular layers of protein, and you have got the nanopore over here through which it can pass, and then there is an activation of the cell within. The DNA itself can be activated and the sequence changed. Platelet mimicry is another one. You find that there is a centrifugation, isolation of the platelets, and it is extracted. And you find that the nanoparticles are being embedded onto the surface of it, as a result of which you find that they are, even the drugs such as the doxorubicin used in cancer are being incorporated in it. And once it is within the platelet, it is like a Trojan horse. It can go to the area of attack. And these are the various uses of it: prevention of cancer, cardiac disorders, in immunotherapy, in diagnostics as a result of markers for tumor, in chemotherapy, etc. And it has got a time reducing potential. And this is again a quote by Richard Feynman. The highest forms of understanding we can achieve are laughter and human compassion. These other future scopes of it: targeted therapy. These are all new words, but probably by the time you people grow up, these will be part and parcel of your career. And again, the scope means it can be anything from a tennis ball up to the muscles of the athlete. They say lactic acid, for example, are all being maximized by means of nanotechnology. There are some limitations over here because of the ethical and other things. The list is given. It can be biological constraints, and who is going to ultimately monitor all of them? That is it. It is a nanotechnology in surgery. That is it. You find along with the cameras, various things can happen. The isolation of the stem cells, and then there is a differentiation into the chondrocytes. Ultimately, you find that can be used for implantation. Again, the miscellaneous uses are there. The snapshots, bacteria, etc. Kindly go through the picture alone. Most of them will be repetitions. A summary again. So all the applications in the healthcare, these have been mentioned, and these are all the various units or products of it. Health environment, what are all the pros and what are all the cons are given over here. Regulation becomes difficult because there is a need for international harmonization, common standardization. Use of academic data can be misused actually. Knowledge and data will have to be shared and stored. And who is to build the cat? Who is to be responsible? Will others be taken advantage of? Are all the problems facing nanotechnology? Thank you.